Imagine a massive dome, 142 feet wide, spanning a temple in the heart of Rome. For nearly 2,000 years, it has stood without the support of a single steel beam or modern reinforcement, surviving earthquakes, fires, and the weight of history itself. This is the Pantheon, and the secret to its survival lies beneath its skin. While modern concrete often begins to crumble within 50 to 100 years, the concrete of the Roman Empire has remained rock solid for 2 millennia. This is the story of Roman concrete, a lost masterpiece of chemical engineering that allowed a civilization to build the impossible. To understand why Roman concrete is so special, you have to look at what happened when the Roman Empire fell. The recipe was largely lost for centuries, and it wasn't until the 19th century that we developed what we use today: Portland cement. Modern concrete is designed to be strong and fast-setting, but it is also rigid. When it cracks, water enters, rusts the steel inside, and the structure eventually fails. Roman concrete, or opus caementicium, worked on a completely different philosophy. It wasn't just a building material. It was a living, self-healing rock. The Romans didn't have the high heat kilns we use today, but they had something even better: a massive, active volcanic landscape. The key ingredient was a specific type of volcanic ash called pulvis puteolanus, or pozzolana, found near the Bay of Naples. When Roman builders mixed this ash with lime and water, a chemical reaction occurred that created a binder far more durable than anything seen before. But they didn't stop there. They realized that by adding chunks of volcanic rock, known as tuff, or even broken bricks, they could create a material that was incredibly strong yet surprisingly light. The true genius of Roman concrete was revealed in their maritime engineering. The Romans built massive harbors, piers, and breakwaters directly in the crashing waves of the Mediterranean. For a long time, scientists couldn't understand how these structures survived the corrosive power of saltwater. Recent studies have discovered that when seawater filters through Roman concrete, it reacts with the volcanic ash to grow a rare mineral called aluminous tobamorite. These crystals actually grow into the cracks, reinforcing the structure from the inside out. Instead of the ocean destroying the concrete, the ocean was actually making it stronger. This material allowed the Romans to move beyond the traditional post and beam architecture of the Greeks. With concrete, they could create arches, vaults, and domes. They could build at a scale the world had never seen. The Colosseum, the great baths of Caracalla, and the vast network of aqueducts that brought millions of gallons of water into the city were all made possible by this gray, unremarkable-looking sludge. It was the backbone of the Roman identity, a material that could be molded into any shape and withstand the test of time. In the construction of the Pantheon's dome, the Romans showed an incredible understanding of physics. They varied the density of the concrete as they built upward. At the base, they used heavy basalt as the aggregate. As they moved higher, they used lighter volcanic stones. And at the very top, around the central opening known as the oculus, they used incredibly light pumice. This gradual thinning of the weight prevented the dome from collapsing under its own gravity. It is an engineering marvel that remains the largest unreinforced concrete dome in the world. But why did we stop using it? When the Western Roman Empire collapsed, the complex supply chains required to move volcanic ash across Europe vanished. The recipe was forgotten, and for over 1,000 years, humanity returned to building with stone and wood. It wasn't until the late 18th century that engineers began to rediscover the power of hydraulic lime, eventually leading to the modern concrete we use today. Today, researchers are looking back at Roman concrete as a potential solution to our modern environmental crisis. The production of modern Portland cement accounts for nearly 8% of global carbon dioxide emissions because it requires extreme heat. Roman concrete, however, was made at much lower temperatures and lasted 10 times longer. By studying the ancient Roman recipe, scientists hope to develop a greener concrete that is more durable and requires far less energy to produce. The story of Roman concrete is a reminder that sometimes the most advanced technology is found in the past. It is a testament to the power of observation and the ability of a civilization to work in harmony with the natural materials provided by the earth. It is a material that turned a city of brick into a city of marble and concrete, and a legacy that still stands tall across the landscape of Europe and North Africa. The next time you walk past a modern construction site or see a crack in a sidewalk, think of the Pantheon. Think of the volcanic ash from the slopes of Vesuvius and the builders who created a rock that grows stronger with every passing century. As the sun shines through the oculus of the Pantheon, illuminating a floor that has been trodden by emperors and peasants alike, do you see an ancient relic? Or do you see the blueprint for a future that is built to last? Thanks for watching.